For today's topic, we'll start with constructors. So, what are constructors? Constructors initialize an object upon creation. So, what do you understand by this? Well, let me remove all of this for the time being and just print the variable L here. So as you can see, when I created a box object here and printed the value of L length, I got a value of 0. So who is assigning that variable to it? Well, that is the job of a constructor. What a constructor does is it initializes an object upon creation. So for instance, let's see what happens when we declare a variable L and try to print it right away without assigning any value to it. So let's see what happens. So as you can see, I get an error here which says variable L might not have been initialized. So might not have been initialized means you have not initialized it with any value. So this value assignment is done by your constructor. So as you can see now, if I run it, this code will run perfectly. So does your constructor assign any value to your class variables? Well, the answer is no. Your constructor assigns default values for your variables. So for the case of integer, the default value is 0. Suppose in the case of Boolean variable, suppose let me call this is square. Suppose let me call this an is square variable, and since we've learned about string as well, let me declare a string variable as well. So now let me again run this code. So I previously printed out L. So let's find out what the default variable for a Boolean is in Java. So now if you don't know what a Boolean variable is, Boolean variable holds only true or false value. So this variable can hold either a true or a false. So let's try printing that. So now again, when I printed out is square, I got an error. Why? Because I did not use the object to call this variable. So let me use an object and call this. So as you can see, for Java, the default value for a Boolean variable is false. So for instance, suppose if you wanted to do something like this, Boolean is square equals false. Now note that these are two different variables. The one here has no relationship with the one here or here. So let me try printing that. So as you can see, I've gotten the value which was assigned here. So important one thing to note here is that this variable is square and this variable is square are two different values. This is square variable is placed in an object of box 1. So again, for demonstration, let me remove the initialization part and run this. As you can see, I've gotten an error here. So finally, let's find out what the default value for a string is in Java. So let me call type. So as you can see, the default value for a string in Java is null. So that is basically what your constructor does. Your constructor initializes your class variables, whatever they may be. Okay, so you see, when you created an object in one of the classes, I told that this was your constructor, and that is basically where your constructor is invoked. So as you can see, a constructor, when you have no constructor, like I have not declared any constructor here, have I? I have not even taught you how a constructor looks. So when you do not have any constructor declared, what Java does is it uses its own default constructor. So the default constructor is called when you don't have your own constructor, but you can define your own constructor, and when you do that, the default one is no longer used. So let me define my own constructor. So the way to define a constructor is that you write the class name followed by parenthesis followed by curly braces. So as you can see, this looks very similar to how you declare a method, right? So the only difference is that you have no return type here. When you declare a constructor, you don't have any return type. Well, the reason is that the implicit return type of a constructor is a class itself. So implicit means indirect. So your constructor indirectly returns your class type. Okay, so I've created a constructor here, right? So in my constructor, I can write some code. So let me write, this is my custom constructor. Okay, so now let me print this. Let's see what happens. So as you can see, now this is my constructor. This line was printed first. So if I actually erase all of this out, you can see that this line is invoked or displayed to the console whenever you create a box object. So what happens is that when you create a box object, your constructor is run here. This part of your line indicates your constructor. So this line of your code gets run, and the job of your constructor is what? Initialize your class variables. And since it has initialized your class variables with their default values, when you print them, you get the default values for them. So that is what a constructor looks like, right? So however, you can also overload constructors. So what do you mean by overloading? So actually, when you overload a constructor, what you actually did here is you overloaded Java's default constructor. So Java's default constructor is not being run when you have this on your own. However, if you comment this out, Java's default constructor will run. So overloading constructors. So overloading means having a different constructor run. So for instance, I can overload this constructor that I've created here as well. So overloading means your constructor will have exactly the same format. The same naming scheme. However, the parameters are going to differ. So for instance, let me write A, B, B, and C. Okay, now what I've done is created a new constructor which has overloaded my previous constructor here. So now the question is, what is the use of overloading constructors? So if you remember, in our last class, we had a method like this. Void set dimensions. We had a method like this that essentially took 3 integer variables and set them to our class variables, right? So we had a method like this. So let me demo this method for you in a second. Box 1 dot set dimensions. So now if I print L after the set dimensions method, I have to pass in some arguments here as values. So I've passed in 5, 6, 7. So that means my class variable L was set with the value that was assigned to A, and A was assigned a value of 5, right? So we had a method that was basically assigning specific variables to our class variables here. So I'll get rid of these two variables for the time being. Okay, so now how about I want to achieve this same thing using a constructor. Okay, so for the sake of convenience, since I'm going to have to print the class variables a lot of the times, let me create a method that does exactly that. Let me call this print class variables or instance variables. So what it's going to do is that it's going to just print out the values. So let me call this length or L. So that is how you have strings in your print statement as well. You write them in quotes. Then if you want a specific integer variable, you use the plus operator. So let me write the value of h here, which is h, and the value of w here, which is w. Okay, so suppose if I invoke this, so now I don't have to separately print out each of the variables. I can just call this method box1.print class variables and it will print the class variables. So I have an error here, looks like a syntax error. Let's try to figure this out, where the syntax error happened. So as you can see, I've used a comma here. So in Python, you can use a comma as well. So anyways, as you can see, I have now the variables printed out in a very convenient form. So from here you can see that I passed 5, 6, 7 as the value for my length, height and width, and that is how they've been set, right? So now let me achieve the same thing that this method was doing using a constructor. So again, my setDim or setDimensions method was basically setting the dimensions for each of my class variables. So now I want to use a constructor. So using a constructor, I can do the same thing. So I'll just copy the code that was in my method in this constructor now. So now previously note how I was creating a class, I mean an object. I was creating an object without passing anything. But as I told you, this is basically your constructor. So now you have a constructor here that can take 3 arguments. So you can pass 3 arguments here. So now let's try printing this out. As you can see, I've gotten the same values as well in my output. So if I were to change them, they would be set the changed values as well. So that is the job of a constructor. However, so let me erase this out. Remember, that is what, your default constructor had a signature like this. Your default constructor, Java's default constructor does not take any arguments, right? But what would happen now if you were to run this code? What would happen? See, you're getting an error which says that required int. So remember, I said that once you define your own constructor, default one is no longer used. So you have defined your own constructor here. Therefore, Java's default constructor, which looks like this, is now no longer being used. But you're trying to call a constructor that looks like Java's default constructor. Since it does not exist, you're getting an error here. So the way to resolve this would be to uncomment this line and say this is my custom constructor which takes no arguments, which has no parameters, just like Java's default constructor. Okay, so now your error has been resolved. Now, how can constructors be useful? See, now that you have 2 constructors, what you can do is use them whichever suits your needs. So suppose if I created this box object like this and printed out the class variables, I would get what? I would get the value 0 here, since this constructor does not assign any specific variables to my class variables like this one. So let's print it. So as you can see that my class variables have been initialized with their default values. So now what I can do is create another object. Let's call this box2, and now I'm going to use my new constructor here. So my new constructor again has 3 parameters. So let me pass in 3 arguments, and as you can see now, if I say print class variables, I'll get 10, 10 and 10 here. So that is how you can create your own constructors as well as overload them. So if you're wondering, yes, you can obviously have a constructor that suppose takes just one variable and assigns that same variable to all your class variables. So how can this be useful? So suppose now you want to create a cuboid or a box which has all the dimensions been equal. So now you no longer have to pass this separately. What you can do is you can just pass a single value, since you're repeating all the values anyway. So let me call print class variables here, and as you can see, I've gotten the same value here. So if you ever want the same instance variable being placed in all your class variables, you can write a constructor that looks like this. So constructors have many other uses. We'll look at them as we move along. So now let's take a look at what is called instance variable hiding. So first of all, it is illegal to declare 2 variables with the same name inside the same scope. So what do I mean by this? So you have already declared an integer variable L here. What would happen if you were to declare another integer variable L here? Let me try running this. As you can see, I got an error which says variable L is already defined in class box. So you cannot declare 2 variables inside the same scope with the same name. However, suppose A, B, C are not very representative of what these variables are meant for, right? How can you know for sure that A stands for L, B stands for H, C stands for width, and so on? So wouldn't it be great if you could write L here, H here, and W here? So what would happen now? So let me change them to their change values. So now what would happen here? Let's try this code. So you're creating a box object here. You're calling the constructor that can take 3 arguments. So you're calling this constructor here, and then you're printing the box variables here, right? So now, as you can see, I've declared an integer L here, which is inside this scope, and if you can see, this scope ends here, which means your integer L variable is inside this scope. You have 2 integer L variables within this scope, right? So you should get an error, right? That is what you saw previously happening when you did this. So let's try running this code. As you can see, I got no error. However, look what happened. Previously, the values that I was passing, which was 10, 10, 10, was being set to my class variables. However, now, okay, so for the sake of ease of understanding, let me comment out these lines. However, now, let me again rerun this. Now, those 10 values have not been set at all. Why is this? Well, the reason for this is instance variable hiding. So in instance variable hiding, when a local variable, so this is your local variable, integer L, integer H, integer W. When your local variable has the same name as instance variable, so this is your instance variable. Your instance variable is hidden. That means when you have a local variable with the same name as your instance variable gets hidden. So suppose whenever you refer to L here, it's always going to refer to this L here. It won't understand this L. It won't know about its existence at all. So that is basically what instance variable hiding is. So how can you solve this? So the way to solve this is, suppose if you want to be able to refer to instance variables even when they have been hidden, the way to do this is use the this keyword. So the this keyword refers to current object. So your current object, which is box 2, it will refer to this object and it will print the class variables. So now let me write this. So now what is going to happen is that if you pass a value of 10, this 10 is going to be placed here and this 10 is going to be assigned to this variable L, which is this variable here, the class variable. So now let me rerun this, and as you can see, my class variables have now been correctly assigned values. So if you ever want to have the same variable name within an enclosing scope, so again, one important thing to note here is that, see, the error that we were getting when we had the same variable name was here, right? When we did this, we were getting an error like this, that variable L is already declared. But when you do this here inside another scope, this error no longer exists. So this error will only occur if you have a same variable declared within the same scope. However, if you do it within an enclosing scope, so I'm calling this the enclosing scope, you won't get an error. Instead, what you will have is instance variable hiding. So again, now you may be wondering that would this instance variable hiding occur only if I have parameters like this, only when I declare them in parameters? Well, the answer is no. So let me try this here. So now if you do this int, so again let me call this L and write this dot L here. So now if you write H equals, suppose 5 int W equals 10. So now your H and W values are going to be hidden. So declaring them here has the same effect as declaring variables with the same name in an enclosing scope. So as long as it's within an enclosing scope, it will have the same effect. So whether it is declared inside parameters or within the scope itself, it does not matter. So let me try running the box constructor that takes just one value. So again, let me run this. And so we have an error here, which is I've used the values A, which does not exist. So let me write H here and W here. So it says cannot find symbol because I do not have anything called A. So let me erase this to L. And as you can see, when I run here, my variable L has been set with the value that I passed. I passed 10, and this 10 has been set to my class variable L. Why? Because I used the this here. Why did I have to use the this keyword? Because when I declared integer L here, my class variable was hidden. Again, when I declared an integer H here, my class variable got hidden. However, since I did not use the this keyword, what happened was that this age variable was being assigned its own value 5. Again, this w variable was assigned its own variable 10. So this lines of code made no difference whatsoever. So again, if I wanted my class variables to be assigned with the values 5 and 10, I would have to use the this keyword. So now if I run this, my class variable will be set with 5, my class variable h will be set with 5, my class variable w will be set with 10, and so on. So that was basically instance variable hiding. Okay, so now let us talk about garbage collection. So what is garbage collection? Well, Java has a built-in garbage collection which removes unreferenced objects. So what do I mean by this? Well, for starters, let me create a box object here. So let me restore this code to its old self. Let me just call this A, and let me write L equals A, H equals A, W equals A. So anyways, I've restored my code to its old self. Okay, so I've created a box object here, right? Well, now what would happen if I did this? Box1 equals new box. What would happen? So if I were to so let me just again, let us trace the first two lines of this code. So I created a box object here and printed its class variables. So my class variables were L, H, and W, and my constructor, custom constructor, which takes no parameter like this, was called. So let me uncomment this, comment this line. So alright, now what I did here was I created another box object here using the constructor that takes just one argument or has just one parameter here. So it takes 10 and assigns 10 to all the class variables, right? However, when I created this new object, I did not assign this object to a new reference variable. Instead, I assigned it to my old reference variable box1. So let me again print box1. What's going to happen is that inside box1, I'm now going to get 10, 10, 10. So what about the box that had 0 values? Well, since you assigned its old reference to this box object, it's going to get lost forever. So I think it would be better if I showed this to you diagrammatically. So let me try starting screen sharing. Okay. So let me explain what I meant here. So when you created a box object here, I mean, we have seen this plenty of times what this line means. So let me again explain. So in this line of code, when you have just written this line of code, what happened was that you had a reference variable created, a reference variable that was named box1, right? A reference variable that can hold an object that can refer to a box object. And when you created this line, new box, what happened is that an actual box object was created. This box object had these 3 variables, and this line altogether means that that box object refers to this object in memory, right? That is what we learned. However, again, now let me trace this line. When we created new box, what happened is that we had another box object created. So with the first one, since you used a constructor that takes no values, your class variables were initialized with their default variables. So in the next constructor, what you did was you passed 10, which meant your 10 was set to all the class variables here. So when this object was created, your LHW had the values 10, 10 and 10, right? However, what happened when you wrote this line, box1 equals new box? So what happened is that basically the old connection here broke, and your box object now formed a new connection, or by connection I mean now holds a new reference, which is the address of this box. So in this way, as you can see, now there is absolutely no way for me to locate this box object, right? There is no way I can get access to this box object. So this is what I meant by garbage collection. So let me stop mirroring. Okay. So what garbage collection does is removes such unreferenced objects. So the box object that was unreferenced is removed by Java's built-in garbage collector, and it occurs sporadically, which means it occurs at irregular time periods. So there is no fixed time when it will happen. Okay, so that was basically Java's garbage collection. So again, what happened was that your unreferenced object So again, this unreferenced object of yours, what Java did is it got rid of it. So this unreferenced object was deleted by Java's garbage collector. So that is basically what garbage collector does. When you have an unreferenced object like this, it gets removed. So that is basically the job of your garbage, Java's built-in garbage collector. Okay, so now we have the finalize method. So finalize method is called whenever an object is about to be reclaimed by the GC or garbage collector. So whenever your garbage collector is about to delete an object, it will call this finalize method. So this finalize method looks like this. So this finalize method, as you can see, has an access modifier called protected. Again, we'll learn about access modifiers when we start inheritance, but for the time being, know that it is different from public and protected. Public and private. It has different access privileges. So anyways, as you can see, this finalize method has a return type which is void. So, and its name is finalize. So this is fixed. So when you have a method like this, when you declare a method like this yourself, Java will always call this method whenever it is about to delete a unreferenced object. So Java will always call this method. So why can a method like this be useful? Well, a method like this, which gets called just before an object is about to be reclaimed by your garbage collector, can be useful for freeing up resources used by those objects. So suppose we will later learn about file handling. So suppose if your object is using up resources for file handling, when you delete that object, those resources will not get freed up unless you free them yourself. So this could be an example of why you want to use a finalize method, to free up resources used by objects that will be reclaimed by the garbage collector. So that is a use case for the finalize method. So now, just like constructors which had the same name here, and same name here, but different parameters, you can also have methods that are overloaded. So I call this constructor was overloading Java's default constructor, this constructor was overloading this one, and this constructor was overloading these two ones, right? So just like you could overload constructors where you had the same name but different parameters, you can do the same for methods as well. You can overload methods as well. So how would an overloaded method look like? So as you can see, it has the same method name but different parameters. So an example would be, suppose void test. So let me write test. Let me just write this test. Okay, so as you can see, I have a method here. So it says cannot find symbol because I did not use a dot operator here. Anyways, so for the time being, let me comment this two out. So I have a method here named test. I can have another method called test as well. However, for it to be overloaded, it must have a different set of parameters. So let's just give this an integer variable as parameters, and let's call this, not call this, let's just print this instead. Okay, so now how would you know which test method is going to get called? So the same concept that was used for constructors is going to translate to here as well. So when I call test here, my test method that takes no arguments is going to get called. In other words, it's printing out this test here. However, if you pass an argument, say let's say 10, you have to first analyze which of these methods takes an argument. You can see this is the one that has a parameter here, and therefore this one is now going to call. As you can see, when I run this, I get this output which was from this method. So obviously, just like a constructor, I can call this two simultaneously like this. So whichever gets called is dependent upon what type of arguments you are passing. So again, you can have, let's say, void test int a, int b, and I can do the same thing here because I can so again, now if I say box1.test, if I pass two variables, this method of mine is going to get called. As you can see, this one got called. However, note that for overloading methods, return type alone not sufficient. Return type alone is not sufficient. So this is basically your return type, right? So what I'm trying to say is that now if I have a method here that says int test, right, and let's just get it to return, say, a value of 5, and let me comment all of this. Let me comment this as well. So as you can see, this method here and this method here, the only difference between them is the return type. So let me try running this. As you can see, I get an error here which says method test is already defined in class box int. So this means your return type is alone not sufficient to overload methods. You have to have different parameters as well when you have the same method name. So I can solve this problem by having this method take an integer as parameter. So again, if I run this, which of my method is going to get called? Obviously this one, since I did not pass any value here. But if I say pass some value here, I'm going to have this method get called, and this method returns a value of 5. So it does not print anything. So to get its output, I can just print the return value directly here, or I could have stored it in some other variable as well. Okay, so that was basically method overloading. So remember, this is very important, that your return type alone is not sufficient. For overloading methods, you have to have different set of parameters as well. So now I want you to think, would this have any problems? I mean, so I want you to ask yourself, I'm going to now run this code. Would it have any problems running? So you have 5 seconds, think about it. Okay. So now, as you can see, again, since this method here and this method here has the exact same parameters, I'm getting an error. So like I said, your return type alone is not sufficient. You have to have different parameters as well. So the way I can differentiate this is by writing double here. So now when I call this method, I'm going to get, when I pass an integer value, I'm going to have this method called, and when I pass a double value, I'm going to have this method called. So let me just write something here which says that this is the method that's being called. So as you can see, when I passed a double value, this method that got called, whereas when I was passing an integer value, the other method was being called. So that is basically method overloading in a nutshell. So now what about passing objects as parameters? So you can also pass objects as parameters. How can you do this? Well, let me create a, so again, for your parameters, the same concept gets applied for constructors as well as methods. So now let me create a new constructor box. And this box constructor is going to accept a box object as argument. So it has a box object parameter here. So suppose, let me say, let me uncomment this and get rid of these things here. So let me say I declared a box variable here. So let me say I have a box variable declared here. Okay, since the azan is being recited, I'll take a short break now. Okay, so let's pick up where we left off. So we were talking about objects as parameters. So you can also pass objects as parameters. So what do I mean by this? So I was creating a new constructor here, right? And this constructor, as you can see, unlike the previous constructors which were only taking, suppose, integer variables as parameters, I now have a box object as parameter. So just like you can pass integer variables, you can also pass objects. In this case, the type of object is box, right? So now how can this be useful? So what I wanted to show you was that suppose I had a box2 object created here, and suppose if I wanted to create a new box object which would have the exact same dimensions as box2, what I would need to do is copy and paste this here as well, right? So suppose if I cannot find symbol. So anyways, as you can see, so to copy basically the contents or basically the dimensions of this box in a new box, what I had to do was pass the same values as arguments in my constructor, right? In this way, suppose box 3 has the same dimensions as box 2, right? So what if I want to copy the dimensions of this box in a different way without having to assign the variables myself, right? That is what I want to do. I want to have the same dimensions as box 2 in box 3, but I do not want to assign these values myself. So what I can do is create a new constructor here like this, and what this constructor does is going to take a box object here, and what it's going to do is assign the class variables with the values of the object that you pass its class variables. So suppose in the case of L, it will be assigned the value that box object L has. So in the case of box object H, W, I'll do the same thing. Okay, so now let's try running this. So instead of passing in values, I'll pass box 2 here, and now let me print this. As you can see, I got the same result here as well. So I hope this was understandable. What I basically or essentially did here was I took an object as parameter. This constructor has a box object as parameter. So you passed box 2's object here when you call the constructor, and box 2's object has length, height and width variables set to 5, 7 and 9 respectively, and therefore what you had here is essentially box 2. You have basically box 2 here, and box 2's L is being called here. So when you call box 2's L, you get a value of 5. When you call box 2's H, you get a value of 7. And when you call box 2's W, you get a value of 9. And these values are set to your class variables L, H and W. And now note that this L, H and W belongs to box 3. So in this way, you can pass objects as parameters as well. So now we have two types of parameter passing. One is called call by value and the other is called call by reference. So which one is which? So when you call by value, what happens is that it copies the value of an argument into parameter. So what do I mean by this? Well, let's get back to basics. So suppose I have a square method here, right? The square method takes an integer variable and it returns. So let me just write here instead like this, that it places this integer, the product of the integer variable that it receives, into the same variable, and then it returns that variable. So let me bring it down here so that the main method's code and this one can be viewed simultaneously. Okay. So I've created a box object here, and now let me call the square method. Okay, so let me create a variable here called num5, and let me pass num here. So now if I print num, what do you think is going to happen? Pause the video, guess an answer, and then resume. So I'll now run the code. As you can see, I got a value of 5 here, whereas I was passing this 5 here and this 5 was being multiplied with 5. As a result, the number 25 was stored in this num variable, and this variable was being returned. So why did I get 5? Well, the thing is, what you did here is that when you pass the value num, you pass the value, you did call by value. So what call by value does is, it copies the value of an argument into parameter. So the value that you passed, again remember that this is called argument and this is called parameter. So when you pass the value 5 here, that 5 value got copied here. As a result, this copy and this copy are different. So these are two different copies here. As a result, you can make whatever changes you want here and they will not be reflected in this place. Why? Because they are two different variables. So for instance, let me visually show this to you again by turning on screen sharing. So let's take a look at what's happening here. So here, your box demo class. So let's just call this box demo and let's call that one box, or better would be box 1. So inside box demo, you have a main method, and inside the main method, you have int num equals 5, right? So this num is in its own separate place. This value is in its own separate place. Whereas when you created a box 1 object, and inside box 1 object you call the square method, this square method did this, so the value of 5 was being, so you pass that value of 5 here, right? So let me change this to exactly calling that method. So I'm basically copying the code that's in the screen right now. So box 1 square num, right? And here what you were doing was, okay, so I'll write this at a later time. So what happened is that when you call the method here, your value of 5 got copied and placed here. So here you have a, so let me call this num, as well. So here you have a separate copy. So when you did num equals to num into num, your separate copy got changed to 25. This one had no changes whatsoever. Why? Because what you did here is known as call by value, and call by value basically copies your argument to parameter. It does not pass by reference, and therefore when you printed, suppose sop num, the number that was printed was the one that was here, and therefore you got 5 here. So that is basically call by value. Okay, so what about call by reference? Well, in call by reference, reference to an argument, again not parameter, not the value, is passed onto the parameter. So here your argument, no type of copying is done. Your argument is passed as a reference. So what do I mean by this? Well, in the case of call by reference, so let me highlight this. So now I'm going to be talking about call by reference. So this was call by value here. However, when you do call by reference, what happens is that your reference is copied. So let me get rid of this. Okay. So in the case of call by value, your reference of an argument is copied onto your parameter, and I'm calling this call by reference. Okay, so what happens is that when you have a call by reference and you execute this line, num equals to num into num5, what happened is that since you do not have a separate copy, your original copy is going to get changed, and therefore suppose if you had printed 25 here, you would get 25. So this is in the case of call by reference. However, note that in Java we do not have call by reference. Everything is call by value. So I hope I have been able to explain the concept or the differences between call by value and call by reference. So again, note that Java uses call by value when passing reference variables as well. So now let us do something interesting. Let us pass a reference variable. So suppose, just for this, let me create a new method. Let's call this. Okay, so I think instead what I'm going to do is end this lecture here since it's getting quite lengthy. So again, before I end, let me just reiterate what I just said. I explained to you the differences between call by value and call by reference. So in call by value, I said that your argument is copied to your parameter, whereas in call by reference, your reference to your argument is passed onto parameter, not the value. However, Java uses call by value when passing reference variables as well. So I'm going to end it with just a simple example just to have you thinking, and I'll want you to figure out an answer for this yourself. So let me quickly just create a method here called void change, or just let's call this assign 10, or just assign default values to class variables. So this is quite a big name. So I've created a method that will assign default values to my class variables, and what it's going to do is it's going to accept an object, or basically a reference of an object here. And what it's going to do here is that suppose box1 dot l equals 0. So by default value, since in the case of box everything is integer, and for integer you learn that the default value is 0. So it's going to assign the default values, which are 0 in this case, box1 dot w equals 0. Okay, so this is basically what it does. So again, let me get rid of this. Let me comment this out as well. Okay, so let's start from here. So as you can see, I've created a box object here which takes the variables 5, 7 and 9, and it prints the class variables. So let's just print the class variables, and it prints 5, 7, 9. Now let me create a new box object. Okay, so instead of creating a new box object, let me call this method here and let me pass this box value as well. So now what do you think is going to happen? This is going to be pretty interesting. So let me print this and show you what's going to happen. So as you can see, I set the value of 5, 7 and 9 here, right? I had set a value of 5, 7, 9 here, and when I printed those class variables, I got this result here. However, when I called this method, what it did was it took box2 here, and okay, let me just change this to box object pretty quickly just to keep things consistent and understandable. Okay, so it received this box object here, right? And it changed LHW to 000. However, when I printed this variable here, this change was reflected here. Whereas in the old case, suppose when I created a integer num equals 5, box 1 dot num, square, and system dot out dot println num. So when I assigned a variable value of 5 to num and called the box square method, which declared integer variable, which was taking this integer variable, right? And then it was multiplying it. But at that time, okay, so I forgot to pass the argument. But at that time, this 5 was unchanged here when I called this method, even though this method was changing this method inside. So this happened because I said that in Java we have call by value. However, here note that when I pass this box object here, it actually changed the value of this box object. Even though I said that Java uses call by value when passing reference variables as well. So box2 is a reference variable. So if it's using call by value, which copies the value of an argument, how come this change is being reflected here? So that is where I'm going to end this in today's lecture. So I want you to figure out if you can explain why this is happening. Clearly I'm saying that Java uses call by value. So Java always uses call by value. There is no such thing as call by reference in Java. So call by reference exists in C, C++, in languages such as those. However, in Java, everything is done by call by value. However, you saw that even though I passed a value here and it changed that value's specific variables, my change was reflected here as well, even though I was passing only a copy here. So shouldn't the changes have been made to this copy here instead of the original one? So that is the question I want you to answer. So with that, I'll end today's lecture.